Hello everybody. I'm recording this video just to help you to understand lab 3 and to do it. So let's first look here in the objectives. The objectives to understand series and parallel connections, analyze power dissipation in a resistor, and develop you are gonna practice on how can you use breadboard. For some students, it's the first time they use a breadboard. Maybe for some students, they have already used it in some other classes. Anyway, so let's start here. As I explained in the lecture, there are three things here. Number one, series. I explained in the lecture how can you tell if resistor are series or not. Okay, they should have the same current. Also, I explained how the voltage is divided across them using a voltage divider. Same thing, how can you tell resistor are parallel or not? As I told you, they have to be connected to the same node. Power dissipation, okay, or this is the amount of power consumed by resistors, okay, is actually V times I, or I square R, or V square divided by R, okay. And as I told you, resistors dissipate energy in the form of heat. Okay. And that's what we're going to see in this lab here. Okay. So the first thing I want to talk about here, let me maximize this one here. Okay. The first thing I want to talk about here is a breadboard. Don't know. Yeah. Let me see here. Okay. The first thing, let me see if I can make a laser. Laser is better. So the first thing I want to explain here is a breadboard. For maybe many of you did not use this breadboard, so I'm gonna quickly explain how you can use it. So in this lab, and I think in all the coming labs, we are gonna use a breadboard like this one here to connect circuits. Okay. As you see here, guys, how it is internally connected. Okay. So let me go to I think next. Yeah. So as you see here, guys, every column here is just one node connected internally together. You see what I'm saying? So if you put one terminal of resistance here and one terminal of resistance here, so actually they are connected together again. So every column here, guys, every column is just one node. They are connected together. Okay. There is a separation here in the middle. You need to understand this separation is separating these columns here from these ones. That means, yes, all this column here, or all this row, or this column, whatever you call it. So this column here is just one node, but this is a separate node. You see what I'm saying? So all these nodes here are connected together, but they are not connected to this one here. Okay, and as you will see in the coming classes, here usually we are going to use IC, integrated circuit, or chips. So usually we put here some legs, some pins of the IC on this side, and the other pins on the other side here. Okay. One more thing you should understand, for this part here, all this row is connected together. So they are connected um, horizontally. These ones here are connected vertically. Okay. Again, what this means? It means if you put a terminal of resistance here and you put another terminal here, that means they are connected together. So everything connected here, that means they are connected internally together. Okay. For this one here, guys, this is all this row here is connected together. This are connected together, and they are separate. These two rows are separate. Same thing here. Usually we use this ones here for the power. So for example, I can make this one 5 volt. I can make this one, or usually make the red 5 volt, or any voltage, a certain amount of voltage, ground. I make the other one ground. And every time in the circuit here, you need 5 volt, you can just connect a wire from here to the node. So all of this just one node, okay, connect from here to a node. Same thing here, you can make this one like negative 10. Sometimes we need positive. Some circuits we need positive, and we need negative, and we need ground, okay. So if this is the case, you can make one row here positive, one row negative, one row ground, and every time you need the positive, you can connect it. Every time you need the negative, you can connect it from here. Every time you need a ground, connected from here. Okay, guys. So again, you can see here, this breadboard is really very, it's going to make connections very easy, because every, as you see here, all this column here, all this part is connected together. It's just one node. Okay, here one node. Okay? And there is a separation here, so this part is not connected to this part. Okay, let me see if I'm missing. Okay. More importantly, guys, I really encourage you to watch this video, and maybe you read this website. It will give you more details on. It's going to show you some videos about how can you use the breadboard. Again, this is very important, because from now until the end of the semester, every time you will use it. Okay. If you don't have much time in the lab, it's just 1 hour and 50. So if you don't know how to use it, you are gonna waste a lot of time in the lab, and you may not be able to finish on time. So it's very important to watch this video, and also maybe you can check this website. You will find details about how to use it. Okay. For example, let's see, because that's what we are gonna do here in this lab. For example, if I connect the resistor this way, guys, here you can see this terminal are connected together, one node. This terminal are connected together. It's very clear. These three resistors are connected in parallel. Okay. If you look at this resistor here, we have one terminal here and one terminal here, and the other resistant terminal is here. So that means these two terminals are connected together. Okay. These two terminals are connected together. These two terminals are here and here connected together. Okay, these two terminals are connected together. So it's very clear that this resistance is a series here. Okay, so here I connect series, here I connect parallel. Again, the idea is that every column here is just one node. Okay, when you use a chip in the future, this is how you should connect the chip. Okay, so that means if you wanna use this pin, if you wanna connect this pin, any node here should be okay. So this pin is connected to this node, this hole. Any one of these holes should be connecting to this one. Same thing for the other one. Okay, and because of this separation, this part is separate from this part. Okay. Anyway, so in this lab, guys, you are gonna use power supply, DMM. Also, you need these resistors, 180 ohm, 470, 1 k ohm. This resistor, and also there are some resistor you need to calculate it in the lab. You need to bring it with you as well. The most important thing, guys, you have to find these resistors before you come to the lab. It's gonna take simply what you can do. You can just do similar to what we did before. You can use the color code to find these resistors. Okay, and you prepare them so that when you go to the lab, you don't have time to search for them. Okay. Another important advice, guys, when just sometimes we make mistakes, right? So maybe you are thinking this resistant, you selected a resistant and you think this is 220 because you made a mistake. Okay, so I advise you, when you go to the lab, after you select this, when you go to the lab, it's gonna take maybe just 1 minute to use the ohmmeter to measure this resistor to make sure they are accurate. Okay, or you didn't make a mistake to select them. Okay. So this lab has 4 parts. In the first part, you are going to connect the resistors in series. Okay, and then you are going to do some measurement to verify Kirchhoff voltage law, and also to verify current division, as I explained in the lecture. So here I'm asking you to connect 180 ohm, 470, 1 k ohm, connect them in series. So the way you have to do it similar to what you did here. So look here, these resistors are connected in series. Okay, and these are in parallel, because we need this one in one part. I think the second part. Anyway, and now after you do that, I want you to connect 10 volt between, as you see here, same thing like this one, but here 1 2 3 4 5 6, here was 6 resistor. We only in this one only using 3. So you see here I'm connecting the power supply between these two resistors. Anyway, so yeah, let me see, 10 volt, and then after that you have to use the DMM in order turn the power on, and then you have to use them to measure the current through the resistor. Okay, remember to put them in series with the circuit. So you want to measure the total current going through the resistor, and then record the measurement in in this part I will show it to right now. 10 of the supply, a picture of the connections. So here also I think you need to measure 10 on the power supply. Use the DMA to measure the power supply voltage and the voltage across each resistance. Okay, so let me, and then you have to record everything in the data and the analysis sheet. So I will show you now. Give me just 1 second. Yeah, just give me a second here. I think. Okay, yeah, this one here. Okay, so let's see here. If you go to the data analysis part in the here in the pre-lab, you can see. Yeah, see, you have to do this one in the pre-lab. You have to draw the circuit, how it looks like. Should be resistance, 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 and then everything connected to one supply. So you have a battery connected to resistant, 3 resistor in series. You need to do, and then you have to calculate the voltage across each resistant. For sure, you can do it in different ways, but I think the easiest way is just you can use current divider, sorry, voltage divider. Okay, and then you have to fill up this part here in this part, and you have to see what the resistor value and what is the voltage. Resistor value and the voltage. Okay, and then after that, for sure, you need to compare between the measurement and the value you computed in the pre-lab, and for sure there are maybe some differences. Okay, this is because there may be some differences, because the resistors have tolerance, also because of the maybe the measurement devices may not be very accurate, power supply may not be accurate. Because of all of these reasons, maybe there may be like a slight difference between your computation and your measurement. Okay, then after you do that, you can prove Kirchhoff voltage law. Okay, you can have to prove the voltage summation of the voltage across the resistor equal to the 10 volt, right? Verify voltage division as well, right? So here, using voltage division, you have a formula to calculate the voltage across every resistor. You can check if this is true or not. Okay, this is the first part. Now let's go to the second part in the here. By the way, I show here the connection just to help you. However, what I did in the one semester, when I made a picture like this one, unfortunately, some student did not understand how to do the connection. They just copied what I did here. But again, this is not true, because in the future, you need to know, if you want to measure voltage, how you connect the voltmeter. If you want to measure current, how can you connect the ammeter? Okay, how can you connect the power supply? Because if you don't understand this lab, you're gonna struggle in the coming lab anyway. So you need to know it, because you will do it all the time. Second part, almost the same thing. We will do the same thing, but this time we are gonna use these resistors, and then we are gonna connect them in parallel. Okay, which actually, yeah, similar to what we did here. And then you need, so all of this just one node. If all of this just one node, okay, and then you connect, I think I told you here to connect 6 volt, and then now I asked you to connect the DMA to measure the current through the first resistor. Okay, measure the current and repeat the process for the 2 resistors. So measure the current here. Okay, so if you go to what you have to do in the pre-lab, number one, you have to draw the circuit, how the circuit looks like. It's very clear. What you have to do here is just 3 resistor in parallel, and then you connect a battery or a voltage source in parallel to them, and then you have to calculate the current across each resistance. Okay, so to calculate the current across each resistor, if you have the voltage with the voltage battery, you can divide it by the resistors. Okay, and then you can calculate, use Ohm's law simply to calculate. This is in calculations. Okay, here, after you do the measurement here, guys, I want you to verify Kirchhoff current law. Okay, so the total current, this should be the current of the supply. See what is the current of the supply, and this should be the total current. If Kirchhoff current law, this total current should equal the summation of the 3 currents here. Okay, also you can check for verify voltage. Sorry, this is not voltage, this is current division. I will correct it. So also you can verify for current division. Okay, um you can use the formula, right? We have a formula for current division. Okay, you can see if this is true or false. Okay, the last one, sorry, the next, because we have four parts here. So in the next one here, okay, is actually power dissipation. Just I want to convince you the resistors, or I want you to understand resistor are actually dissipating or consuming powers or dissipating power in the form of heat. So what you have to do here, you have to use 560 resistor, and then we're gonna exceed the rating, the maximum current. And you will see how it is heated. You'll see some heat. Okay, for sure. You have to be careful here because as I told you here, the resistor will become hot during operation. Be careful to avoid burns. Don't perform this part directly on the board, because if the resistor is too hot, overheat, this may damage the board. So try to do it when the resistor is out. All what you have to do, just one resistor, you connect it to a voltage source, and to change the value of the voltage source so that you can exceed the maximum current. So how, what value of the voltage you have to, so again, you have to connect only one resistor direct outside the board, connected directly, okay, to the voltage source. What values? Okay, you have to calculate in the pre-lab. So in the pre-lab here, I'm asking you, calculate the voltage needed to achieve the following power dissipations in 560 ohm. Okay, you know the power should equal V square divided by R. Okay, so here for the different values here, for example, 1 over 16 watt, okay, should equal to V square divided by this R. Okay, and then you calculate what is V. So what is the voltage of the battery? Okay, that is gonna make this dissipation in 1 over 16 watt. Do the same thing. Finds what is the voltage is gonna make the dissipation 1 over 8, 1 over 4. I think most of the resistor you have is 1 over 4. So until 1 over 4, I guess you should not feel any heat, because it should be lower. For sure there is a heat, but this heat should be very, very small. Okay, you may not feel it because it's lower than the rating, power rating, or the maximum power. I think it started from one half, and what you will start it is it becomes too hot, and if you leave it for some, or even if you increase the voltage, it may make a smoke, it may burn out, you may damage it. So you have to be careful in this part. Okay, so if you go to here, what you have to do here, guys, yeah. So here you need to write. Calculate the power. This is something you need to calculate, and you need to see what is the voltage, measure voltage, and then write the temperature. What do you feel about the temperature? The last part here is actually the last part here in this lab is actually, yeah, we want to make a resistor that is 10701. However, this is not a standard value. So if you check in your kit, you are not gonna find this one. Okay, so does it mean you cannot make it? The answer is no. You can make it, but you have to use multiple resistors to make it. Okay, so I want you to see what resistor you have to use to make this value of resistors. Okay, so you can use more than one resistor for sure. You need to see how can you connect them series or parallel, so that you can make this resistor here. Okay, by the way, and I have posted all the values of the resistor you have in the kit. You see what I'm saying? So look at this one, try to see this, open this file and see what resistors do you have, and try to see how can you connect the resistor to have this resistor. Okay, all what you have to do, you have in this part, just for example, you found two resistor series, one parallel, whatever. Okay, you need to connect them, and you need to measure. You use ohmmeter to measure the total resistors, and make sure it is equal to this value. Okay, so, and also, let me see here. Yeah. So here, the circuit resistance measured value equal whatever, and then you have to measure the individual resistors measured values. Okay. For sure, there may be some difference between them. No, sorry, there may be a difference between these values and the values in the pre-lab. Okay, simply because because of tolerance, for sure. That's here to design a circuit to achieve a resistance of 100 sorry, 1701, using a combination of this series parallel or a combination of series parallel connection, whatever you do it, okay, using your lab kit, try to minimize the number of resistors. Okay, I think that's it. The most important thing, guys, it's not difficult lab. However, you have to prepare for it before you go. Otherwise, 1 hour and 50 minutes may not be enough. Okay, so you have this is important thing. You have to do it. The pre-lab is a must. If you don't do it, we are not gonna get zero in the pre-lab. You need to prepare for the lab. More importantly, guys, if you don't understand anything here in this lab, you are gonna struggle next time. So you need to understand if you wanna measure voltage, how you should connect it. If you wanna measure current, okay, so because you are building a circuit right now, so that's what we're gonna do in all the coming labs. Okay, thanks very much, and have a good day. Bye.